So remember earlier I told you that we can get the delta H of a chemical reaction for any reaction? That's what we will do now. We will get the heat of a chemical reaction. Remember, delta H Rxn. And we can do that in the lab, or we can use the tabulated information. The tabulated information has delta H of formation in it. Delta H of formation. So we will use those values, the heats of formation, to calculate heats of reaction. Let me show you how. It says, find the heat of the reaction of the following reaction. So this delta H reaction is unknown. That's Rxn. Here, we can either go to the lab and mix 4 moles of this, 5 moles of this. We get this, put it into a calorimeter, and see how the energy or the heat changes. Or we can find the heats of formation using the table. For how much energy did it take to form NH3? So all we have to do is look it up. NH3, and you have to pay attention to the physical state. It's a gas. It gave off negative 45.9 to form it. Kilojoules for every mole. Okay, so this is negative 45.9 kilojoules for every mole to form it. How much energy did it take to form oxygen, O2 gas? So I look here. Well, common sense tells me oxygen is already diatomic gas, so it's going to be 0. It took 0 energy to form it, so I'm going to put 0 kilojoules per mole. How about, I'm going to draw a line here. How about NO gas? So I look here. How much energy did it take to form NO gas? It took 90.3 kilojoules per mole. 90.3 kilojoules per mole. How about water gas? So I'm going to go water. So notice there's a difference between the gas and the liquid. Make sure you pick the right physical state. Negative 241.8. Negative 241.8 kilojoules per mole. Okay, so these are the heats of formation forming every single one of these substances. Since this is for every 1 mole and this says 4, I have to multiply this by 4 moles. And that will cancel, and I will get the total energy for 4 moles. This one I'm going to multiply by 5 moles, which is going to be 0 anyway. This one I have to multiply by 4 moles. And this one I have to multiply by, I'm going to write it here because there's no room, 6 moles. That cancels. The moles cancel. When I multiply this, I'm going to get kilojoules. And I'm going to, of course, add these together. I'm going to do this plus this one. So this is negative 183.6 kilojoules to form both of these together. So I add them up. Okay. And these, I'm going to add them together as well. When I add those together, it's going to take negative 1089. It's going to give off 1089.8 kilojoules. The moles cancel, as you can see. Okay, so it took this much energy for the reactants to form the reactants, and this much energy to form the products. Okay, to get the heat of reaction, delta H of Rxn, I have to do the heat of formation of the products minus the heat of formation of the reactants. Okay, that's the formula. So I'm going to do equals. The products is in red, negative 108 9.8 kilojoules minus this minus is this minus, and then the reactants is in blue, minus 183.6 kilojoules. And the answer is going to be negative 906.2 kilojoules. Okay, now this is the delta heat of the chemical reaction. So this is this answer right here, the heat of the chemical reaction. And I'm just going to say, I'm going to add this in. I know that the moles got canceled, but since this is for the whole reaction, for every mole of this chemical reaction, that means for every one of these, if I double these, I'm going to double this number right here. So what did I just do? I just found the heat of reaction. Here it is. For this chemical reaction, did I have to go to the lab? No, I didn't. I got the heat of reaction by using the heats of formation that is tabulated, and all I had to do was add the products minus the reactants, and I got my heat of reaction. Okay, the book will give you this formula right here. This is the heat of reaction, which is negative 906.2 kilojoules equals. This is the sum. That means I'm just adding the heat of formation of the products. The M means the moles. So when I multiply the moles, minus, so this is the products minus the reactants. Same thing as what I did here, but this one is just a little bit more fancier with a summation, meaning to add it right here. Okay,